NASA, back in the early 90s, released a 5-volume set of space sounds. Unfortunately, they were none too specific about how the sounds were made exactly. All that was stated was that each track represents the sounds from a different object, like Jupiter, Saturn, or Uranus. Now, you might be thinking, how was NASA able to record sounds in outer space? The recordings weren't actually of sound coming from those planets. What was picked up were interactions of charged particles in the planet's magnetosphere, trapped radio waves, and other electromagnetic disturbances. NASA then took these measurements and converted them into sounds. It is similar to the way that your radio captures the radio waves from radio stations and converts those signals into sound. And this is also what is used to detect the largest explosion in space so far. There are processes in space that produce noise in the sense of random, or approximately random, variations of emitted energy. The classic example is radio noise generated by stars. People correctly note that you can't have sound in a vacuum. You can have propagation of pressure waves and shock fronts in many nebulae. These processes will be subject to noise as well, though I don't know if such things can be observed or measured. While it's true that sound can't propagate in a vacuum, outer space is by no means a total vacuum. But since gas in space is extremely diffuse, what sound is there propagates at extremely long wavelengths and extremely low frequencies. Hearing such sound will receive a receiver thousands if not millions of kilometers across. Since space is an imperfect vacuum with sparse particles, sound can still vibrate through space if the force of the sound is large and strong enough. Cataclysmic and not-so-cataclysmic events make sound in space. Black holes, quasars, galaxy mergers, supernovas, molecule hydrogen clouds, and stellar collisions make sounds in space. They just do not travel very far before the vibrations diminish in energy, running out of enough particles to transfer from the further the waves move. Infrared sound is emitted by stars. Galaxies are collective stars, the accretion of black holes, and the electromagnetic field as it vibrates. These events are too far away to travel to Earth, except for the infrared sound of some objects and events. So, telescopes and satellites never receive sound waves from such distances. Also, humans can only hear sounds between the range of 20 to 20,000 hertz. A hertz is a vibration per second. Any sound lower or higher is beyond the capability of human hearing. Also, in the emptiness of space, particles are very sparse, too sparse to transfer sound vibrations that humans can hear, but that doesn't mean that the devices we send to space can't either. A record-breaking explosion created by a black hole has been discovered by astronomers, which probably has its roots near the center of our galaxy. The center of the Milky Way is a weird place. The region is literally overflowing with stars. Within a parsec of the galactic center, the estimated density of stars is about 10 million stars per cubic parsec. By contrast, the density of stars in the solar neighborhood is 0.2 stars per cubic parsec, and there's a whole lot of dust at the galactic center too. Therefore, astronomers can see nothing in visible light, ultraviolet light, or even low-energy X-rays. The only thing astronomers can detect are radio waves, and there are some strange signals coming from the center of the galaxy. Yes, astronomers have discovered a transient source of radio waves coming from the center of the Milky Way. The research team knew they had found something remarkable and unique because it started almost invisibly, became very strong, faded away, and then reappeared. They tried to match the signal with everything they knew, like low-mass stars, pulsars, magnetars, and variable stars, but none of them matched the signal. This led to them deducing that the source must have been a black hole, and a huge one at that. Contrary to popular belief, black holes don't just gobble up everything in their path, but also emit beams of material that are able to evade the event horizon. These are the radiation scientists can pick up on. The energy that was created by this explosion was 5 times greater than MS 0735 plus 74, once known as the largest and most powerful explosion picked up by astronomers. The eruption is said to have left a giant dent in the Ophiuchus galaxy cluster, and researchers report their findings in the Astrophysical Journal saying, "I've tried to put this explosion into human terms, and it's really difficult. The best I can do is tell you that if this explosion continued to occur over the 240 million years of the outburst, which it probably didn't, but anyway, it'd be like setting off 20 billion megaton TNT explosions every thousandth of a second for the entire 240 million years. So that's incomprehensibly big, huge. One thing is certain. The signals are coming from the supermassive black hole in the middle of our galaxy, in the Ophiuchus supercluster, which contains thousands of galaxies. Astronomers studying the supercluster discovered an explosion that must have been so huge they considered it the biggest explosion in the history of the universe. Scientists had long thought that there was something strange about the Ophiuchus galaxy cluster, which is a giant aggregation containing thousands of individual galaxies intermingled with hot gas, plasma, and dark matter. US and European X-ray telescopes had spied a curious curved edge to it. The speculation was that this might be the wall of a cavity that had been sculptured in its plasma by emissions from a gargantuan black hole in one of the core galaxies. Black holes are famous for gorging on infalling matter, any gas or even stars that happen to get too close. But they can also expel prodigious amounts of material and energy in the form of radio jets that then slam through the local environment. Scientists at first doubted the black hole explanation. However, because the cavity was so big, it implied the black hole emission would have had to have been unimaginably large. But new low-frequency telescope data from the Murchison Wide Field Array, or MWA in Australia, and the Giant Metric Wave Radio Telescope in India seems to confirm the theory. Professor Johnston, who directs the MWA, explained, this object was actually observed with the Chandra X-ray telescope by a previous team, and they saw this bubble in the hot X-ray plasma in the center of this galaxy cluster, and they said, well, this can't be from one of those energetic outputs because it would be enormous. The scale would be unthinkable. So they dismissed that possibility. But we went back and observed with low-frequency radio telescopes and discovered that this cavity is filled with radio plasma. This explosion was believed to be the result of an energetic outburst and was so powerful it punched a cavity, a crater, in the plasma surrounding the supermassive black hole. And it is not an ordinary cavity. It is large enough to hold 15 Milky Way galaxies. Active black holes have a disk of gas and dust swirling around them. The material in the disk can get so hot that it begins to emit X-rays and gamma rays. Some of these black holes produce jets of charged particles at close to the speed of light, and sometimes there is a violent outburst. It is not known exactly how these jets are formed. So far, more than 200 black holes with such jets have been observed. For example, just last year, the Event Horizon Telescope captured an image of M87, the first ever image of a black hole. M87 emits a jet of matter that stretches about 5,000 light-years into space. A question arises. Was it really an explosion like a big bomb going off? The question arises because the physicists say that the explosion was slow and it occurred over a few million years, kind of like an explosion seen in ultra-slow motion. We need to wait for further reports to know conclusively. So there you are, guys. I hope this video offers some good insight. If you enjoyed it, be sure to hit that like button and subscribe for more content like this. And as always, thanks for watching.